Okay, hey, I'm Roman Vinicio, and I'm gonna explain the eighth problem of the exam. That is approximation through Taylor series for integration. Okay, so we got this equation here: 8x cosinus of x to the fourth. That we can know that if this is our u, this cannot be our du because we need another power. Okay, so then, since we cannot do it from other methods that we know, we're gonna approximate it through Taylor series. Okay, we are gonna take, instead of this fx, I just name it like that, we're gonna take the gx, that will be cosine of x, okay, or principal equation here. Now we are gonna do our table, where we are gonna be liberating for every n we have here. Every time it's another derivative. So we start with our cosine, then go to minus sine, minus cosine, sine, cosine. Okay. Now we substitute the middle, that will be between 0 and 1, and then we had just a substitution. Okay, now we have to take this value here and multiply it for x minus our center, that is 1/2, times n, well, elevated to n, and everything to the n factorial. Yeah. Now we substitute every value we had and just get all this stuff. Okay, it's kind of messy. Now, since it's difficult sometimes to get like the rule we're gonna have here, we can go straight to the approximations through the sum. We just take the values we had, we treat them as a sums, always put in the dots, please. And now we can approximate our value. We know that fx, that is our original, will be a transformation of 8 times x multiplying the gx, the g function evaluated in x to the fourth. Okay, so we go to the next step here. It will be approximate. Remember, it is just approximations because we don't have all the values of the sum. And we start taking our 8 for 8x cosine of 1/2, and I decide to take out like some, like, to group or values that have cosine, and we see that we have cosine here, so it will be a 1 times 8x. Okay, then we had another cosine here that will be our minus, but this time we have a value here that will be appearing and is divided by 2. Okay, next cosine we had is summing, and same stuff, we took out this cosine and we just keep this part. Okay, we do the same with the sine, we just have 2 sines here because the number of values we took. And now we start the evaluation, kind of the evaluation, and we got that the 8 cosine of 1/2, it's going to be multiplying everything here, like all our derivatives, but our derivatives has binomials and we are gonna have to split them. How does it will look like? Well, maybe something like this. Okay, we can see it's kind of really messy here. So the 8x we were multiplying, we are just gonna take the x that will be inside the integrals every time because it's an x. And well, we started here, we had a 1 before. I mean, we need to watch it, sorry. we used to have our 1, and now it's the x that multiplied before and the dx. Then we had the next part that was the other cosine, but this one has a binomius third to the third, yeah, and we split it in the best way we know. Okay, it's just splitting all the values we used to have. Here we'll be splitting an fourth times binomials. So we start with this, that will be 16, but because the x we had here, it will turn it into a 17. Same stuff here. We go to the sign. We had two signs. Here is our first sign that is to the binomial, a binomial square, and here we have the other one that is a binomial cube. Binomial cube, yeah. Okay. This was just a multiplication, and this is a binomial cube. Yeah, they jump the ends. Now we evaluate. Well, we split. We integrate, and because integration, we are going to be taking the values. We have an x dx, we have an x squared over 2. Then we have the half multiplicating all these integrals, and these integrals have extra fractions that are inside. So we had a 7, no, we had a 9, it turns into an n to the under 10, yeah. We take out also here the x5 will be a 8/6 under 6, but since we have here a fraction, it is gonna multiply what we were gonna have, that was an x squared under 2, will be multiplying and giving us an 8. Same stuff here. We will take out this for now because we got two big numbers if we don't do it. And now we are gonna have our 18 under 18, 13 turns into 14. We had a 2 here, so it's gonna take out the 14 and turn it into a 7. Then same stuff here. We had a 6/4, so at the moment we would have the 10, it will be just a third 20s. Also here we had the 12, that is gonna be the 6 power, but under 6 plus the 1/2 we have here, and keep more of the same stuff here. We have an x squared under 2 that will be multiplicating the 16. Okay, now we go to the sign, and the sign would be more of the same but with shortened values. The 5 will turn into 6 under 6. The half will be multiplicating here the square over 2, so we will have a 4. Everything plus everything 1/6 times, and well, more of the same. Now we evaluate. Here is the only beautiful part of everything, because everything is x, so it will be just like fractions. So we start summing all our fractions, 1/2. Here we have 1/2 multiplicating all the fractions we had here, that it's 7 over 120. Same here. And well, and then we go to the most beautiful part, that will be the sign. And well, the sign will be more of the same, but the beautiful part, is here when we substitute by 0, because since they are all x, everything will turn into a 0, and we got to work just with the part of the 1. Now we just proceed to multiply our cosine for the value we got here, and also the 8 times sine for the value we got here. So we get these two sums that will approximate our area to this value. Thanks for listening all this long story.